Hi, I'm just creating this video because I'm really excited about the final year thesis project that I created. The name of the project is Use of IoT in Timed Up and Go Test, which is also known as the TUG test. TUG test is a gait analysis technique to predict fall risk in the elderly. With age, people are becoming more prone to falls because of frailty. Frailty is your muscles and bones get weaker with the age. So when you're walking, there's a tendency of falling down. And by the United Nations population data, it has been observed that the number of people who are above the age of 80 years will be multiplied by three in the year of 2050. So it'll increase up to 16% of the entire world's population, which will result in huge risk of falling with times to come. It has been observed that a lot of money is spent on treating these fall-related injuries for the adults. And this is the second leading cause of unintentional injuries for the people who are above the age of 65. It's only second to road traffic accidents. So having that in mind, the best gait analysis technique to predict risks of falls is the timed up and go test. It is a observer bias test which is done mainly in lab settings. So a patient comes and sits on a chair. At the word go, they stand up, walk 3 meters, turn around, come back to 3 meters, turn around and sit back on the chair. The entire time taken for this process is measured, and they say if the patient takes less than 13.5 seconds, they don't have a risk of fall. If they take more than 13.5 seconds, they don't have a risk of falls. If the people take more than 13.5 seconds, they have a risk of falling. But this is, as you can see, it's an observer biased and a time biased system. So the proposed sensor I created is I trained an Arduino RP2040 Nano microcontroller with the six phases of the TUG test, and I input data in the gyroscope and accelerometer. I trained the data, I labeled the data, so the microcontroller can understand if it's standing, if it's walking, if it's turning. Those phases they can understand. And I created a k-means anomaly detection learning block as well, which can see if there are any outliers from the normal walking patterns of a human. So when there are outliers, it predicts there's a risk of falling in the individual. So with adding more data, we can of course improve the sensor module's accuracy, but currently I'll show you what's happening in it. So it's based on RP 2040 Connect microcontroller. It's a robust and a small sensor module. You don't have bulky equipment to wear around it. This is very cost effective, and you can wear it on a pouch like this and have it in your belt, and the weight is just 30 grams. The dimensions are really small, and the cost I spent on this is just $100. This is more than half of the price on the current modules in the market, and they are not so user friendly. So the results I obtained are like this. So when I trained the data, it segmented the various stages of the TUG test into a scatter plot, and then it is matching the input data with this scatter plot and predicting if the gate is okay, if the gate is not okay. Right. And then there's a GUI, graphical user interface, for the user to see if their gate is okay or not. And then I created a ChatGPT based AI chatbot where you can upload these results and have a conversation with the AI software. So this is more analytical, and then you can get your personalized feedback and talk about how you can improve your gate with this ChatGPT based Tug Master AI. All right, now let me give you the results analysis. The accuracy came up to 77.9, and it had a tendency of predicting 96.4% when it came to fall risk. And the other phases were not so much good because the accelerometer sometimes detected standing up as walking, sitting as standing. Those things could be calibrated a bit more, but the potential of using this in healthcare is massive and the cost is really low and it is so user friendly and the device is so small. You could practically train it a bit more and we can use it in healthcare. Let me show you some live demonstration to before wrapping this video up. Right, okay. This is the Arduino IDE. So it is currently inferencing data, so it's sampling. So let's say if I move this sensor module slowly like this as a person's walking, it is saying it should predict the risk of falling, and currently it's showing 0.99%. So when you have like different gate like this with various anomalies, the fall risk is really high. So the same thing would be shown in the graphical user interface when we reload it. And then we can take a screenshot of this graphical user interface or the Arduino IDE we have it here and then upload it to the TUG Master AI, which I discussed earlier. Right, so this is currently being loaded. See, you can see the fall risk now was updated to 0.1%, which is like high risk of falling. Right, so if we can take a screenshot of this one, take it and go to the TUG Master AI. We can upload it here and we can have a meaningful conversation with an AI chatbot. And if you think that we can improve our gait, we can ask questions like, how do I improve my gait from this chatbot? And it will help us even in fitness related problems or diet related problems. I have trained this ChatGPT based chatbot with those data. I have uploaded research articles to this and I have trained him with fitness related information. So he's good as it can be. So I recorded this video because I was really excited about what I did. I don't know if I'm going to post it anywhere, but if I do post, just share what you think about what I have created. Thank you so much for listening in. Cheers, guys.